In this video, we're going to continue considering design factors in the context of the World of Zuul project. And we're particularly going to think about the concept of refactoring in this video. When classes are maintained, then code is often added, and classes and methods tend to become longer. When we're undertaking modifications to code, either to add additional functionality or to improve its quality, we should be always keeping in mind the fact that new opportunities for improvements might be being introduced by the processes we're undertaking. So we should allow for processes of further refactoring within the change process. If we think about where we've got to with the room class so far, we've managed to significantly reduce the degree of coupling between the game class and the room class by introducing encapsulation into the room class and requiring all game objects to go via accessor and mutator methods in order to interact with the internal structure of the room class. But so far, by and large, all we've done is shifted code from the game class to the room class without considering whether there are knock-on effects that we could take into account and further improve the quality of the room class. In particular, we're going to look at the fields of the room class and consider whether the current structure really supports the kind of flexibility that we want. We've talked about the idea of adding further exit directions such as up and down, and will simply adding more fields support that kind of extension in the most appropriate way? Or is there an alternative way of implementing the navigational structure that will ultimately improve the overall quality of the class? Before we look at the room class in detail, we just want to note that actually there still remains a degree of coupling between the game class and the room class that we might want to do something about. In particular, the point at which the game is set up, the game object knows a significant amount of information about the nature of the exits in the room class. It makes a single call to each room object to say, here are the rooms that you're connected to in each of the 4 compass directions that are implemented within the room class. If we're going to introduce further directions such as up and down, do we really want the game class to be aware of that and to have to add another 2 parameters to the call to the setExits method? Isn't that embedding a little bit too much detailed knowledge of the internal structure of the room class in the game class, and can we do better than that? So let's bear that in mind as we think about how we might refactor the room class in order to improve its extensibility and maintainability. Here's the room class with its 4 fields for each of the 4 directions a player is able to navigate from one room to another. Let's also look at the code where the values of these are set and where they're queried. Here's the getExit method that receives a string and then performs a series of tests on that string to determine which of the 4 fields it should be returning. One point we actually note is that writing 4 separate if statements like this is not a terribly good way of performing the logic. For instance, we know that if the direction is north, then there's no point testing to see whether it's east or south or west. So strictly speaking, we should have really written this as being a series of if-else decisions with a terminating else that sets the next room to be null in the case where none of the exits matches. And in fact, if we do that, we can remove the initialization at that point, and this is actually quite a good stylistic approach to take. We want to avoid automatically initializing local variables where the value of that variable is meant to be set in all cases by the remainder of the code. And this provides us with a nice safety net. For instance, suppose we'd forgotten that final else part for the case where none of the strings here matches the one that's passed in. Note that the compiler is giving us an error message, and the error message is that the variable next room might not have been initialized. Well, it certainly wasn't initialized up here. That's something we've done deliberately, and it's making clear to us that there's a route through the method body that could lead to no match in any of these cases, and the value of the variable will be undefined because it hasn't been set via the logic of the code. And that's the reason why we place the else part here, to cover the case where none of the other options matches. And the compiler is happy with that because it can tell that in all routes through the method body, the value of this variable will be set, and therefore a meaningful value will be returned down here. Here's the setExits method, which we just noted was called from the game class, where a parameter for every single field within the class needs to be received in order to set each of those fields. So this really is exposing the internal structure of the room class to any other class which wishes to set any exits. So it would be nice if we could get away from this explicit list of all the possible exits and perhaps have something that allows us to say, in a given direction, this is the room that you're connected to. So it would be nice to have a method, something like setExit, that takes a room object as a parameter and a direction string, and then sets the appropriate exit for that string. So actually let's code that now, because that's something it would be nice to introduce, and we can do that fairly easily within the current structure of the game. So it's going to receive an exit, it's going to receive a direction, and then we can use something like this structure here to perform the main task of the body of the method. We copy and paste, and then all we need to do is change each of these values to be exit and the appropriate variable over here, north exit, east exit. What about the else part in this case? Does it matter if a direction string has been passed in which doesn't match one of the potential room exits? We could potentially print an error message here, for instance, indicating that the direction is not recognized. But the problem we have, of course, is that any communication that is being made to the player of the game rather than the developer of the source code. So strictly speaking, this error should be triggered because there's a logical error in the development of the program, and really printing out an error message like this is not appropriate. The issue is, of course, that if there's a logical error in the program, then really the developer needs to know about that before the program is shipped out to its users. So we really need a more sophisticated mechanism than is provided by simply printing output. Here's the code that we would really like to include within this method in order to indicate that to the developer, and I'll leave it here without further explanation because it's a more sophisticated topic than we really want to cover at this point within the book. It is covered in a later chapter when we deal with error handling and more sophisticated testing within programs. So what we have now is a method that allows us to set the room exit in the given direction, and we can fully document that. Now that we have this method, we can go back to the game class and replace these calls to setExits with setExit calls for individual destinations along with the associated direction string. Here's how that might now look in the game class. Let's now return to our consideration of whether we have the best implementation structure internally within the room class or whether we can do better. We're now in a position to completely remove this method. It's no longer required. Here's another example of where we are in effect iterating through all of the possible exit directions and then appending a piece of text into the string builder. Now, one thing we might note is that the parameter to get exit in each of these statements is exactly the string that we then wish to add into the builder, although it has an additional space afterwards. We note too that this generally is a series of independent if statements. We wouldn't want to turn these into if-else statements because we definitely want to check each of the directions north, east, south and west. Again, thinking about other directions that we might add, we would have to copy and paste an if statement and append it immediately afterwards. And this code is going to gradually grow longer and longer and longer as the number of exits increases. As I just said, in effect, we're performing a kind of iteration. We have a list of strings that we wish to test, and for each of those, if the result of calling getExit is not equal to null, then we want to append that string into the builder. Because it seems like an iteration, even though it's written as a linear sequence of code, could we actually turn this into some form of iteration? And the answer is yes, we can. We could easily define an array of strings which lists all of the directions that we know are exits from a room. For instance, north, east, south and west. And then simply iterate over that array and ask if the exit in that direction is not equal to null, then append to the builder the direction that we just checked and then append a space in order to ensure that the formatting is as it was before. And this for each loop along with the array is completely equivalent to this block of if statements. And one of the effects we can now see is that if we want to add other directions, we simply add another string into the array. So that's quite a nice improvement to the way that this method works, simply by enumerating all of the possible directions in one place and then iterating over those directions. However, let's go back to the fundamental nature of the way in which we're representing exits within this class and consider again the fact that it doesn't look terribly extensible to simply have to add further instance variables every time we want a separate exit direction. How might we do something different if we go back to the getExit method here and consider what's actually going on here? What we're saying is that there's an association between particular strings, north, east, south and west, and a room object. And if we think about the way that we can associate two objects with each other, a string and a room, an obvious data structure that we've already met is the Hashmap. In effect, what this method is doing is performing a mapping from a string to a room. We pass in a string, we want to return a room object, and that's very much like the way that the get method of a Hashmap works. We pass a string as a parameter to the get method and we'll return a room from the get method if we have a map from string to room. So that gives us a clue as to the way that we might replace this not terribly extensible way of representing exits by using a hash map instead. So let's explore that idea. Private hash map string room. We're going to call that exits, and in the constructor, of course, we're going to initialize that. The compiler has reminded us that if we want to use a hash map, we need to have an import statement. And now the getExit method is simply going to be exits.get direction, and the result of that is something we want to return. And we note that if the direction is not recognized, so if there is no room in that particular direction, then the get method will return the value null, which is exactly what would happen in the previous case. So we can now replace the whole of the body of that method with a call to exits.get direction. So suddenly we're seeing that the use of a map here significantly reduces the amount of code that we require to perform one of the fundamental operations, which is how do we return the room associated with a particular string. Of course, we haven't solved the whole problem yet, because we also need to make a similar change to set room if we're going to get rid of north exit, east exit and south exit. But what's going on here? We're in effect performing a put. We're saying that we want to associate with the string north this particular room object. So the equivalent operation here is to say exits.put, where the key is the direction and the associated value is the room in that direction. And that performs exactly the equivalent of the set of if statements down here. Now, we've lost the ability to indicate that there may be some directional exit that's not recognized, but actually this turns out to be an advantage, because what it allows the room class to do is effectively take any string that we might want to use within the game, north, south, east, west, up, down, left, right, whatever we wish, and associate a room exit with it. So we're no longer constrained by a set of explicit strings that are hard-coded into the room class in order for the game to operate. So in a sense, we're introducing further decoupling into the program as a whole by saying the room class doesn't actually need to know anything about the kind of strings that are used for the directions of the exits. So the refactoring process will actually completely remove from the room class all knowledge of the way in which connections are made between rooms. It's simply aware of the fact that there's an association between a string and a room, and it needs no further information than that. So we're getting to the point now where we can remove these fields because they're not going to be explicitly referenced within the room class. There's one more place that we need to make some changes to. So having said that the room class has been completely decoupled from the concept of explicit directions, we need to address the fact that we are listing explicit directions here. We listed the directions in this array because we wanted to be able to perform an iteration over all of the possible directions in which exits were possible from a room. If we're not to list them explicitly here, where can we get that information from? And the answer is we can get it from the hash map. So the hash map consists of a set of keys and associated destinations. And that set of keys is precisely the set of directions in which there are exits from this room. So instead of having an array here, we can ask the hash map for its set of keys. And the hash map will now return all of the keys associated with valid exits from this room. As a result, we no longer need to go and find out whether there is a room in that direction, because the key set will only return keys that have an associated exit. Therefore, we can remove this test. So we iterate over the keys and we append the associated direction, because we know that there's an exit in that direction by virtue of the fact that it exists as a key within the hash map. Just to check to make sure that we haven't broken anything. So you're outside the main entrance of the university, exits east, south and west. Go east in the lecture theatre, go west, go south, and so on. So we don't seem to have broken anything. One change that we will note, however, is that when a key set returns the list of keys, we have no control over the order in which those keys are listed. In the previous version of the game, we had control over that by virtue of the fact that the directions were listed in a particular order in the sequence of if statements or in the array that we replaced those if statements with. A set has no ordering, and so one ordering might be northeast, southwest, another might be southeast, west, north, and so on. So we need to be aware that the order in which directions are printed might differ from room to room. We've now put ourselves in a position where we can introduce things like the ability to move down from a given room. So here we've introduced a new room called the cellar, and we've indicated an exit in the down direction from the lab. So let's see whether that works. We go south, and we note that down is listed as an exit, and there we are in the dark, dank cellar full of old computers. So we've achieved our goal of refactoring in order to make it easier to add new features, and we've added very easily the ability to add new directions where the direction is named in one place. This is the only place in which knowledge of the fact that down is available as an exit direction is placed. It's been completely removed from the room class, so we've decoupled that aspect between the game class and the room class. We originally had that embedded in both of those classes and probably assumed that rooms would need to know about available directions, but we've removed even that knowledge. So we've engaged in a process of refactoring, but an important aspect of that has been that we've been testing both before and after the refactoring process. So we established a baseline for how the game worked before we engaged in any kind of code changes. And then when we've made code changes, we've compiled and we've rerun the game to make sure that the changes either have had no negative effects on the functionality we saw before, or have indeed successfully introduced the new functionality that was our aim. So refactoring and testing go hand in hand, and it's important to allow time for both of those to take place. Now there's one further aspect of coupling that we haven't explored. We noted that the class diagram gives us some hints about coupling that exists within the program, in that the association arrows on the diagram tell us whether one class is dependent upon another. But that's actually not always the case. That doesn't always give us the complete picture, and I want to illustrate an example of what we might call implicit coupling that exists within the game to show that we just need to be a little bit careful, and testing is going to sometimes expose issues that we hadn't necessarily thought of. So let's return to the game and introduce a little bit of new functionality to it. We note that when we play the game, the program tells us what's going on within a room when we arrive, but there's actually no way of getting that information back again. So it would be nice to add a look command that essentially reminds us of what's in the current room, what the exits are, and so on. So we'd like to be able to type look and have it say, for instance here, you're in a dark, dank cellar full of old computers. Because as the game develops and moves on, we're likely to introduce more text into room descriptions. There may be items within a room that we pick up and drop and so on. And it would be nice to remind ourselves of what the current state of the room is. So let's think about how we might add a look command into the program. When we explored the game originally, we noted that the list of all available commands is here in the command words class. So we obviously need to add the word look into that list of valid commands in order for it to be recognized. We note that there's been some knock-on effect in the parser. We ought to have a look in there to see if there's anything particularly significant that we need to do. In fact, there's no explicit knowledge of the various command words, so we have no further changes to make to the parser. The other place we'll have to make some changes to is in the process command method, because this is the method that actually examines the text of the command word, and depending upon whether it's help or go or quit, we'll call the appropriate local method. So we now need to add a further test, else if command word is look, then we'll follow the same pattern and have a method that mimics the name of the command word. So we want a look method. That method is going to print details of the current room. And we'll just keep this simple. All we really need to do is call print location info, which is the method that prints out the room's long description. Compile, play the game, and now when we type look, we get a repeat of the description that was previously given, and we can type that as many times as we like. We can go east, and look works here as well, and so on. So everything appears to be fine. We've added some new functionality and we've tested it out and things are looking good. However, there is some implicit coupling that we failed to recognize, and we can illustrate that by typing the word help. Help lists our command words, and it tells us that our command words are go, quit and help. So it doesn't list look as an available command word. What we're discovering is that there is somewhere within the source code that makes assumptions about what the available command words are, but is not getting that information from the command words class, which lists that information. So let's go back to the game class and see how this arises. Here's the help method. And we notice that here are the command words hard-coded inside the print help string. This is clearly unsatisfactory. This list of words should really be obtained from the command words class. If we go back to the class diagram, we can see that there is no association between game and command words. So the coupling is implicit, not explicit. What we really need to do is provide a method inside the command words class that will return to the game a list of all the valid command words. Here's the method that we've introduced into the command words class that provides a list of all the valid command words that are derived from the valid commands array. Notice that because this array is a static array, we can define the get command words as a static method and then allow the game class to invoke that method directly on the command words class. Here is now how the game class can gain access to the definitive list of available command words, and of course if any new words are added to the list of valid commands, no further changes to the print help method will be required. Looking at the revised class diagram, what we now notice, of course, is that a fresh association has been introduced into the diagram between the game class and the command word class. In other words, what was previously an implicit coupling between those two classes has now become an explicit coupling that's represented on the diagram. So the final bullet point on the diagram recognizes that resolving issues like implicit coupling might result in that coupling becoming explicit. So although that might appear to suggest that we've increased the coupling within the program and therefore made it of lower quality, in fact we've still improved its quality because we've exposed the fact that coupling existed that we weren't previously aware of, and therefore it makes it more likely we will be able to take that into account in any future changes within the program without getting tripped up by it. As a review, we can say that changes to code sometimes lead to opportunities for further improvement, and we've seen significant improvements in the quality of the room class as a result of the changes we've made here, and indeed the result has been further decoupling between the game class and the room class. Refactoring is an important aspect of maintenance, and it's essential that time is built into any processes that consider maintenance or development to ensure that refactoring takes place. We've also seen that sometimes coupling issues are not always explicit within the code, and we can easily get tripped up by implicit coupling, and it's a good idea to make implicit coupling explicit in order to avoid unforeseen errors.